Hi everyone. We are going to continue our discussion of hypothesis testing and learning all the ins and outs. And I thought I would start with just a little bit of a review because for most of you, I think this is a very new topic. So remember that hypothesis testing is essentially testing two hypotheses, HO and HA. And that's why I have two boxers going at it here. So one of the hypotheses is HO and the other is HA. And only one hypothesis can win. HO is the hypothesis that says you have null, nada, nothing. So in other words, when we're doing research and we are using samples to run our experiments or our studies, we find something and we need to know whether what we found in our samples is attributed to just sampling error. In other words, it's just a fluke. Whatever you found is only unique to your sample. Or did we find sampling error plus something else, and that something else being a treatment effect? And so HO is the hypothesis that says whatever you found in your sample, that's just sampling error. It's unique to your sample. You will not find it in the population. So he's a bit of a negative type of hypothesis, right? He's, you got nothing. Now, HA is maybe a little bit more optimistic, and HA is going to say that whatever we found in our sample is not unique to the sample. In other words, we've got something on top of sampling error. So HA is not going to deny the existence of sampling error. HA can see sampling error just like anybody else can, but HA is going to argue that there's something else going on and that something else is a treatment effect. So if we were to test the entire population, sampling error would disappear, but we would still be left with a treatment effect. So there's something going on. And so we use hypothesis testing to try and figure out what our data support. Do the data support HO, in which case we're going to be pretty disappointed because all we have is sampling error? Or do the data support HA? And in essence, they're saying you've got something that is over and above sampling error. Okay? And then last time we learned that if our data support HO, then we are going to say that the results are not significant. On the other hand, if the data support HA, then we're going to reject HO, and we are going to say that our results are significant. All right, and then we left off with this discussion here. Let me just bring this all up once. So I went through a little box like this, and I showed you how we have 4 possible outcomes for hypothesis testing. So in other words, whenever we do hypothesis testing, we're using samples. If you were testing the entire population, then hypothesis testing would not be required because hypothesis testing is specifically done on samples. But when we work with samples, remember that we're only estimating. When we work with samples, we don't have all the data. So what this means is that when we work with samples, we may come to correct decisions or we could be making mistakes. All right, and that's the nature of the beast. When we have incomplete data, we do our best not to make mistakes, but they can still happen. And so we ran through this particular example where I said, pretend that you could in fact know that HO is true in reality or false in reality. Now this is fantasy land because in reality we don't know if HO is true or false. The only way to know if HO is true or false is to test the entire population. All right. So this is fantasy land. So we're just pretending that we did know. HO is true, HO is false, and then we look and see what our statistics will tell us to do. Because when we do a hypothesis test, the statistics are either going to say retain HO based on the results of the test. We're either going to retain HO, or we may get test results that tell us to reject HO. All right, so those are the two options, retain HO or reject HO. And then we went through the 4 different possibilities, and we said, well, if you are retaining HO, so in other words, your statistics are saying to keep HO, retain it, and HO is in fact true, then that's good. You kept a truth, right? So you've made a correct decision. But if your statistics are telling you to retain HO and HO is actually false, well, you don't want to keep a false HO, but that's what you've done. And so we call that a type 2 error. So it's keeping HO when you should have rejected it, because you should reject it if HO is false, right? All right, so this one down here, our statistics might tell us to reject HO. But what if in reality HO is true? You have just rejected the truth, right? You've rejected a true HO. That's a type 1 error. And then the last one is if you reject HO, because that's what your stats are telling you to do. So you reject HO, but HO was in fact false. You've rejected a falsehood. Well, that's a correct decision. So there are 2 ways of making a correct decision and 2 ways of making an error. But once we do what our stats tell us to do, like for example, if our stats say to retain HO, then we narrow it down to just 2 possibilities. Either we've made a correct decision or a type 2 error. If we reject HO, because that's what our stats is, that's what they're telling us to do. So once we do that, then we have narrowed down the 2 possibilities to either a type 1 error or a correct decision. All right, so if we have rejected HO, there's no way we can be up here, because in order to be up here, you have to retain HO. Similarly, if we retain HO, we can't be down here, because to be down here, you have to reject HO. All right, so do you see how that works? Once you've done what your stats tell you to do, you're in either one of 2 boxes. All right, and we covered also another way of looking at type 1 and type 2 errors. We said type 1 errors are like false positives. All right, type 1 errors are like false positives because you think you have something. Your stats are telling you you do, right? Your stats are going to say, hey, reject HO, your results are significant. But in reality, you have nothing. So it's like a COVID test saying, you've got COVID, but in reality, you have null, none, and nothing. You don't have COVID. That's a false positive. A type 2 error is a false negative, because a type 2 error would be essentially taking a test that says, oh, you have nothing. You don't have COVID. Null, none, and nothing, right? You don't have COVID. That's what your stats are saying. But HO is false in reality. In fact, you do have COVID. And so that would be a type 2 error, where you think you have nothing, you think you're safe, but in reality, you have something. You have COVID. So it's a false negative. All right? So that's where we left off last time.